All right, let's talk for a moment about the basics of FlexConnect. We'll dive into the details a little later, but let's talk about the basics. Now, FlexConnect is really a solution for a branch or remote office. What we're doing here is we're allowing a connection to take place at a site where a wireless LAN controller just isn't a good idea. We can't afford it. There's not enough APs in play there. So what we're going to do is we're going to set up FlexConnect so we have centralized configuration and control, but this is going to be at the headquarters. This is not going to be at the branch office. The branch office is actually going to have APs, but they're going to be set up in FlexConnect and point back to the wireless LAN controller at headquarters. Now, this is supported by most Cisco APs, so chances are if you've deployed a Cisco AP in your environment, as long as it's fairly modern, you have the ability to run FlexConnect. Now, there's two modes of operation for FlexConnect. There's connected mode. This means that we can reach the controller. Basically, what this means is we can reach headquarters, right? Whenever you think FlexConnect and the controller, what you're saying is you have connectivity to your home office all the way to that wireless LAN controller. Now, what happens in connected mode is we get help from the controller to complete client authentication. We actually use it for central switching when we do that. We'll talk more about that in a second. Next up is standalone mode. Now, standalone mode for FlexConnect means that all of a sudden we lost connection to the controller. So cannot reach the controller. What I want you to remember here, connected mode is what you want. This is the normal behavior of FlexConnect. When we're in standalone mode, that means there's some type of issue or problem that took place. So we no longer have connection to that wireless LAN controller. Now, when we are in standalone mode, we process clients' requests based on the local settings and rules. So this may or may not be an issue. And we're going to dive into this in a little bit, but standalone mode can cause all sorts of issues if we have centralized authentication and we have other issues going on in the background to where these local settings just aren't enough to get us back online. So the goal is to stay in connected mode, but we need to plan for what happens when we lose connectivity to that wireless LAN controller. Well, that's one of the drawbacks of FlexConnect, really. When we lose that connectivity to that headquarter office, FlexConnect kind of has to default back to standalone mode. Now, there's two switching modes in FlexConnect. There is centralized switching, or central switching as they say it. That means all data is tunneled back to the controller. All this wireless LAN data, that's tunneled back to the controller, and the controller at headquarters figures out what to do. So we have a tunnel set up between the AP in the branch office all the way back to the headquarters, and inside the headquarters, that's where the wireless LAN controller is. That's where the traffic hits that AP and is tunneled directly back through that DTLS encapsulation. More about that later. We also have local switching. Now, local switching allows 802.1 tags to be put into place, and the AP to deliver the traffic to the wired side locally where it is. So no tunnel taking place for the data of the wireless network there. So these are the different modes. We have connected mode and standalone mode, and we have central switching and local switching. Please know these terms. I'm going to be referencing them as we go forward in this lesson. So let's look at these two terms. Like we've already defined it, but let's do a diagram to help you get the full gist of what's going on here. I'm going to grab an arrow, and this arrow, let's make it a different color. Let's make it a little bit of teal. Let's talk about locally switched client data first. This is what many people think of when they think of wireless activity. This is the type of data flow they see in their heads. Okay, so the client generates traffic, right? And this traffic flows up to this AP, and then the AP puts it up to a switch, and then it is moved around in the remote office just like you think any normal traffic should be. That is locally switched traffic. That means our network, where we are using 802.1 Q tagging, is going to make sure that everything goes where it belongs. The AP is going to put wireless traffic on a specific VLAN, and then that VLAN is going to be routed through our wired environment as any other traffic would be. Now that differs quite a bit from centrally switched client data. Now, centrally switched client data is a little bit different. Let me change the color to give you a full, I'm going to pick a good color. There. So let's talk about centrally switched client data now. Now let's take a look. Let's say we're this client now. Now this client is not any different. We are still attached to this AP. Ooh, goodness. We are still attached to this AP right here. Now that AP is still in the same network, the same general network right here. So what we're going to do is, instead of delivering the traffic directly to our normal switching process, our normal routing process, to be delivered to our own nodes within this local area network, what we're going to do is actually tunnel traffic back. You see this CapWAP tunnel right here using DTLS. That CapWAP tunnel, this is Datagram Transport Layer Security. I keep saying DTLS. I have to reference that, right? So you guys are, what in the world is he talking about? No, DTLS, Datagram Transport Layer Security. So layer 2 security encryption. And what we're going to do is we're going to create this trunk right here. And this trunk is going to take my wireless traffic. As soon as it hits this AP, we are going to be tunneled all the way back to the main office wireless LAN controller. Yeah, using our VLANs. Yeah, absolutely. Interesting, isn't it? What's going to happen at that point is, now once we reach that wireless LAN controller makes all the decisions. That makes the decision on what wireless LAN is attached to what VLAN, and what VLAN determines how we're going to be routed. And now we're not routed here. We're not back here. We don't come back here. We are routed from this point forward. Remember, there was a lesson on anchors early on in the wireless course. If you haven't taken that lesson, you need to go back and take a look at it. This is explained. This is kind of like an anchor. What is really interesting, what I would like to see a hybrid version of, and there's not yet, is this. Let me explain the issue with this. This is, we're going off course right now, okay? This is my problem with this current system. So what happens is, what if this node wants to talk to this node on the wireless network? And we are using centrally switched client data. Let me show you what happens here. Instead of us using the wired network to just come right back down to this other AP and going across, we don't have that ability. We go up right back to the wireless LAN controller. The wireless LAN controller defines the data, right, with the VLAN or whatever, and decides, it looks up into the frame. The frame says, oh, we're going to this VLAN right back here. Same one we started on, right? So we're going right back to here. What happens is, we come all the way back through the infrastructure back to this node. This is one of the weaknesses for me personally of centrally switched environments. That's why they say this is useful in small, remote, or branch offices. The larger this becomes, the more this link right here, let me switch to my pencil, the more this link right here is going to be taxed. Now remember, this link is just a logical tunnel. What we are really utilizing, let me pull this all back. What we're really utilizing is what? That wide area network link right there. Now that wide area network link is going to be responsible for all traffic. If I have multiple wireless nodes that are going to communicate with each other, forget about it. What I've done is overtax this one single wireless access wide area network link. So be very aware, in a centrally switched client data network, be very aware of, what's that link? What's my throughput? Can I handle the load I'm going to place on it?